All right, so here I'm supposed to reduce the circuit below into an equivalent capacitor at terminals A and B. What you have to remember for this is that capacitors add the opposite of resistors. So when I have when I look at this, things that are in series, I'm going to combine those with product over sum. So this 6 and 12 will become 6 times 12 over 6 plus 12, which is 72 over 18, which is 4. And so I can now rewrite this circuit, or this set of capacitors, like this. I've combined the 6 and the 12 microfarad to get a 4 microfarad, which is in parallel with a 6 microfarad. Now, capacitors that are in parallel add like resistors in series, so I can just add those two together now. And so now I have a 10 microfarad capacitor, and then another 10 microfarad capacitor, and then a 3 microfarad capacitor, and an 8 microfarad capacitor. So now I have a 10 microfarad and a 10 microfarad in series. So whenever you have identical capacitors in series or identical resistors in parallel, the equivalent is just going to be half. So I can do product over sum, but it is just going to be a half. So then I would get 8 and 3 and 5 and now my 3 and 5 are in parallel, so I can just add them. So then I've got 8 and 8 in series, and what will 8 and 8 in series be?
4.
And so our answer is 4 microfarads. Let's, yes, yes.
So on something like this, would these just be in parallel because they're in the middle?
Yeah, I'll draw that and I'll show it, yeah.
Okay.
So the question was, and it's a really good question, because these kinds of circuits stumped me for a while, trying to figure out from the point of view of A and B, would these capacitors be in series or would they be in parallel? And so I want y'all to think about this and see what you can come up with and see what your explanation would be. Are these in series or would they be in parallel from the point of view of terminals A and B?
That's gotta be parallel.
They're parallel.
They're parallel.
No, they're parallel. Yeah, they're parallel.
So if you move like A and B a little bit closer, this is the fact that there's two.
Yeah, no, I got
be in series.
Say that again?
Since there's not anything in between like A and B, they technically be like on this, like the circle, on like the loop, wouldn't they? So then that make them in series.
Well, it's so you need to keep in mind that A and B are they are, I mean, let me think about it this way. So if you think of A and B as kind of like sticking up out of the page, then A is going to here on this one and to here on that one. So this would be this would be capacitor 1 side A, capacitor 2 side A, and then B is over here, and now you can see that they are in parallel. I don't know if I drew that in any sort of helpful way or not. But if we think of think of A and B as having like A and B as being A being the plus terminal and B being the minus terminal. The two capacitors all have one end connected to the plus terminal and the other end connected to the minus terminal, and so they are in parallel. So how could I draw one where they were in series?
If A and B were all on the same side.
Yeah, A and B were on the same side. Let's go ahead and do problem 8, and then I'm going to take a 5-minute break. Okay, so problem 8, we have 10 millihenry inductors, so we want to add these together like resistors. So you can see that these two right here, can you see that those two right there are in series?
Yes.
Okay.
Now all 10 microhenries.
They're all 10 millihenries. 10 millihenries. So these two that are coming up out of the page are in series, and together they'll be 2L. And then I have this other resistor or inductor right here in series with this inductor right there, and they make another 2L inductance. So if you look at this without my drawings on it, you've got this one little triangle is 2L, this other little triangle is 2L, and they're all in parallel.
Ooh, that rhymed.
Oh, it did rhyme. So what is 2L and 2L in parallel? 1. So I can now say L, 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 and L. So now I have L and L in parallel, and what would that be? Uh-huh. So that's L, that's L over 2, and that's L.
Wait. What's that picture right there?
The green one?
Yeah.
Okay, so this triangle was 2L,
What did you do before that one?
nothing.
Nothing?
So this triangle is 2L,
Yes.
this triangle is 2L,
Okay, never mind.
and all three, that 2L and the 2L and the L are all in parallel.
Okay.
It's just kind of a 3D picture because they're just kind of weird the way they're situated. And now all our L's are in series, and so this combines to be 2.5 L. All right. Any other questions? All right, so I'm going to stop and take a 5-minute break, and then we'll start back right after 7 o'clock, so 7:01.